Hi guys, here we're going to talk about vapor pressure. This is in Unit 3, Section 2. So you'll need your notes, your Unit 3 packet, and you'll also need Table H. We will be writing on Table H, so make sure that you have that with you. We'll go through what vapor pressure is and interpreting Table H. So make sure that you have, again, Table H is out in front of you right now. So vapor pressure. The first thing I actually want to talk about is what a vapor is compared to what a gas is. So a vapor is anything that when you change the temperature, that substance goes into a gaseous form. So technically it's different than a gas because at STP, or standard temperature and pressure, we have those those elements on the periodic table that are in the gaseous state. So remember we had talked about the rule of 17. So number 1 was hydrogen, then you start at number 7, nitrogen, go over and down to make the number 7, and then chlorine is number 17. And then we add helium to that as well. So all of those are gases at STP. A vapor is when that gas is actually when a liquid turns into a gaseous state, but not at standard temperature and pressure. So vapor pressure is the pressure exerted by a gas in a closed container with a solid or liquid at a given temperature. So pretty much if you had a container, like an Erlenmeyer flask, you had some water in there, and then you had water vapor in there as well. You close up the container, and the vapor pressure is pretty much all of those water vapor particles colliding with the sides of the container. And as the temperature increases, the vapor pressure will also increase. So you increase the pressure. The rate of evaporation, so when those particles in the liquid state will evaporate into the vapor state, that is equal to the rate of those vapor particles condensing into a liquid state. So we have a diagram here on the lower right hand side. Here you can see particles. They can all be, let's just pretend they're all water. At the bottom you have the liquid state. There's the forces exerted by gravity, there's closer intermolecular forces. The dots at the top, those represent water vapor water vapor, so water when we kind of think of it as a gaseous state. The stronger the intermolecular forces are between those particles, the lower that vapor pressure is. And boiling point is when the temperature equals the vapor pressure. So we actually have a diagram here, and this is what a typical vapor pressure graph would look like. You have temperature on the x-axis and vapor pressure on the y-axis. And then as you increase the temperature, that vapor pressure, all those forces colliding against the sides, all of the forces caused by those particles colliding with the sides of the container, that will increase. Recall that as we increase temperature, the average kinetic energy increases, and there's more pressure being built up. Alright, so this is a typical vapor pressure graph. Let's take a look at Table H. So you have 4 different compounds here: propanone, ethanol, water, and ethanoic acid. From Unit 2, we should be comfortable with what each of these are. Prop means that there's 3 carbons. The one means that this is a ketone. So use Table R to help you kind of think about what the structure looks like. For ethanol, eth means that there's 2 carbons. And the OL tells you that there's an alcohol group, so an OH group to it. We know what water is. Ethanoic acid, so eth tells you that there's 2 carbons, and the oic acid also tells you that it's an organic acid. So we'll look at the graph here. If I take any one of these at, say, 50 degrees Celsius, I'm going to actually draw a line at 50 degrees Celsius. At 50 degrees Celsius, ethanoic acid happens to have the lowest vapor pressure, followed by water, then ethanol, and then propanone. Okay? So at the same temperature, all 4 of these have a different vapor pressure, meaning the pressure are those, again, particles colliding with the sides of the container. So here we have to think about which one has the strongest intermolecular forces. Recall in the last slide that we talked about the stronger the intermolecular forces are, the lower the vapor pressure. So when we look at these, we have to look at whichever one has the lowest vapor pressure, and I just randomly picked 50 degrees Celsius. You can use any of these. Ethanoic acid has the lowest vapor pressure, so ethanoic acid has the strongest intermolecular forces out of the 4 of these. Propanone had the largest, oops, I don't even know why I had this here, sorry guys. Alright, so right over there. Propanone has the highest vapor pressure, so this actually has the weakest intermolecular forces. Alright, so make sure you make that little correction. I don't know why I randomly put a line at 50 kPa, I apologize. So let's actually go ahead and talk about the unit, kPa. We know this is kilopascals, and we'll say that actually right here, 101.3 kilopascals is actually at STP. This is also equal to 1 atm. So some of the questions you might ask you, what is the normal boiling point of each of these four substances? So if I look at the normal means standard conditions are at STP. So at STP, we're going to look at all four of these. Go down, and then you can read what each of those would be. All right. Also go ahead and take the time to label what each of these small little increments are as well. So we have 5, 10, 20, oopsies, sorry. Let's make this a little bit better. 5, 10, here's 15, that's 20, 25, 30, 35, so on. So these go by fives. So here at normal or standard conditions, propanone's temperature, so the temperature at which propanone would boil would be about, so that's 55 and that's 60, so about maybe 58 degrees Celsius. So here would be 58 degrees Celsius. So propanone would boil at normal or standard conditions at 58 degrees Celsius. Let's take a look at water. At normal conditions or at STP, water will boil at, hey, look, 100 degrees Celsius. We know that. So if you have friends who live in higher altitudes, they actually have to, their water will boil at different temperatures than 100 degrees Celsius. So that's why STP is really important, standard temperature and pressure, because we do have people who live at higher altitudes who have a lower vapor pressure, or atmospheric pressure, excuse me. So that's kind of how you interpret Table H. In your packet, you'll have a set of questions. This is actually what the first one looks like. So I'm going to grab mine. Here's this: liquid will boil when its vapor pressure equals the atmospheric pressure. So again, when vapor pressure equals the atmospheric pressure, whatever temperature that is, that's where that's where that substance will boil. Notice here, this is in torr. Our last one, or in Table H, was in kPa. You might actually have questions, some of the multiple choice questions which have you use Table H, where it asks you in millimeters of mercury or in ATM or whatever, so you have to be able to convert kPa into all the units that the multiple choice questions want you to have. So make sure that you have those pressure conversions handy for yourself. So here I have my y-axis in torr, and recall that at 760 torr, that's equal to 1 atm, or conditions at STP. So we can look at substance A, B, and C, and it may not be obvious on your paper. A and C might look exactly the same, so make sure that you label them appropriately. Alright, so let's look at the questions. At what temperature would liquid A boil at an atmospheric pressure of 400 torr? So we have to look at liquid A and at 400 torr. So if this were A, oopsies, sorry, let's go back. Alright, this is A, B, and C. So it wants 400 torr. So we'll go at 400 torr, come on down. Oops, sorry guys, my cat is actually right here with me and she is shaking my screen, so she doesn't want me to do any work right now. Okay, there we go. Much better. Alright, so this is liquid A at 400 torr, so this would be about 37, 38 degrees Celsius, however you interpret it. And again, it's easier for you to do it on your own papers than it is here. Alright, so 400 torr. The next question we'll ask is about liquid B, so I might as well do that while I'm here. I'm going to go over and down, make your line a little bit better. And I have about 68 degrees Celsius. So this was 68 degrees Celsius for liquid B. And then let's take a look at liquid C. Again, that question wants you to do at 400 torr, go across and down, so that's about 96 degrees Celsius. Alright, so that's how you answer questions 1, 2, and 3. Question 4, and I might as well, since I'm here, I might as well have that here. How low must the atmospheric pressure be for liquid A to boil at 35 degrees Celsius? So we want liquid A, and we want it to be at 35 degrees Celsius. So I'm going to take 35 degrees Celsius up and over, and so that would be about, let's say, 375 torr for that one, for liquid A. Question 5 asks me about liquid B, still at 35 degrees Celsius. So I'm going to take 35 degrees Celsius, go up and over. That's about 200 torr. And then we'll take liquid C, and that's about 75 torr, approximately. Alright, so the question after that, number 7, what is the normal boiling point of liquid A? So let's think about when it talks about normal, it wants us to do standard temperature and pressure. So we know at standard conditions 760 torr is equal to 1 atm, or 760 torr is 1 atm, 101.3 kilopascals. That's standard conditions. So we will find where we are for liquid A. And again, you might be able to interpret this a little bit better on your graphs. I have around like 54 degrees Celsius, maybe around there. Then, let's see, it wants liquid B for question 8. So let's go down. I have about 80 degrees Celsius there. And for liquid C, I have about 110 degrees Celsius. So again, my graph, my horizontal line isn't as horizontal as I need it to be. But you can kind of get the idea of how you would read these. And then for number 10, which liquid has the strongest intermolecular forces? The best thing to do here is just take any one of these lines, any one of the temperatures, and go up. So I'm going to take 30 degrees Celsius, just because I randomly chose that one, it doesn't matter. So liquid A would be 300 torr. Liquid B would be about 200. And liquid C would be about 50 torr. Recall from the relationship, the strongest intermolecular forces has the lowest vapor pressure. So in this case, at the same temperature, between all three of them, liquid C actually ends up having the smallest vapor pressure, therefore it has the strongest intermolecular forces. Alright, so to quickly summarize, well, just kidding. I don't know, I thought I did. Alright, so to summarize, vapor pressure is the pressure exerted by a liquid or solid, well, actually when they're all in the vapor state. It's a closed container, it's a closed system, and you can use Table H to help you. So let me know if you guys have any questions. During the multiple choice section, take your time, read through every question carefully. We haven't gone through absolutely everything because there's so much to do for vapor pressure, but look at the questions, look at some of the answer choices as well, and see which one makes the best or most sense. Alright, darlings, have a great day. Take care.